It's interesting to note that each hospital had a physicist on staff to run these machines, or at least to oversee the different physical devices that the hospital was using. After every one of these incidences, the local hospital physicists called the company and the Medical Regulations Bureau for their countries. At first, the company denied that their machine, the Therac 25, was capable of delivering an overdose of radiation. They believed that the machine had so many safeguards in place it was impossible. In fact, it frequently threw errors and paused treatment, giving minimal, less than the actual required amount of radiation for many patients. After the, I think it's the third, but after the Canadian incident, it was clear that something was wrong. The only way that the Ontario patient could have received the kind of x-ray they received is if the turntable was in the wrong position. If the scanning magnets or the x-ray target were not in position, the patient might be hit with a laser-like beam of excessive radiation. The company carefully ran test after test and could not reproduce the error. Now, this situation is due in part to the types of tests we were running at the time. Each of our tests that we ran, I cannot stress this enough, each of our tests that we ran at the time assumed that the operator was doing everything according to the book. We also assumed that the hardware was working correctly. So when we ran tests, we didn't check to see what happens when the software isn't working, or what happens if the hardware isn't where it's supposed to be. So the only thing they could think of was that those micro switches had failed and not given, because there were three all ganged together, and not given a particular response. So the micro switch circuit was redesigned such that if even just one of the micro switches failed, the computer would detect it. So they thought the alignment was perfect when all three micro switches were in place, but they only had one sensor to sense that. So they redesigned it in case one of the micro switches was out of place. This modification was quickly added for the rest of the accidents. Now, in East Texas, they had 2 of these within a month, and the physicist on staff was quite concerned. So this write-up says, I think it's cute, if this story has a hero, it's Fritz Hager, the staff physicist at the East Texas Cancer Center in Tyler, Texas. After the second incident at his facility, he was determined not to proceed. In both of the cases when they overdosed the patients, the Therac 25 displayed an error message called malfunction 54. The message was not in their manuals, but the company knew that malfunction 54 meant that the Therac 25 could not determine the actual dose. Couldn't determine if it was an under or an overdose of radiation. It meant that the machine could not decide how much radiation had been delivered to the patient. Because it was the exact same radiotherapist who had been there when both incidents occurred, the physicist brought her back into the control room to attempt to recreate the problem. In fact, they locked the doors NASA style. That comes from the Columbia accident, when the Columbia broke up over Texas, and they were trying to figure out what was going on, and they were working on partial solutions, and when they finally realized that Columbia was totally lost, they literally said, lock the doors, nobody goes home till everything is documented. So they locked the doors NASA style and worked into the night and through the weekend trying to figure out what the heck went wrong. Can we make the machine do it again? The technician kept running the machine, trying everything that they had tried possibly to do before. And finally, they were able to figure out something. When they used the console to enter the Therac 25's prescriptions, they used the cursors to move things up and down the screen, up and down on the machine. This was a pretty new interface. If the user selected X-ray mode, the machine would start setting up for the high-powered X-rays. Took about 8 seconds. If they switched to electron mode within those 8 seconds, so if they moved to one, it hadn't finished yet, and they remembered, oh, I don't need that one, I need the other, and they switched to electron mode, the turntable would not switch to the correct position. Instead, it was in an unknown state. They didn't know how the turntable was aligned when they switched in the middle of the choices. Now, don't forget, the testing we did back then was really designed to make dang sure that we followed the manual. A manual was written. You guys don't even know what manuals are anymore. You don't read them. You just Google things. We had manuals for everything, and we were supposed to follow them exactly. And we tested to that manual. So if the manual said, put it here and wait 8 seconds, we didn't test what happened if it moved 4 seconds before we finished those 8 seconds. So all the testing on the machine had been done slowly and carefully according to the manual. The problem was that this bug would never have been identified by the testing they did. When you're testing your systems in the future, remember to try and say, what would a user do that I'm not anticipating? But we weren't asking those questions back then. So it took the technician who worked every day with the system to be able to reproduce the error because she knew what she did sometimes. Even with this knowledge in hand, I forgot to mention, every time they did this, they were able to make the malfunction 54 show up. So they got it down to an art, and they were able to reproduce this message. But even knowing this, it took a bunch of phone calls and conversations with the corporation that built the machine in order to get their technicians to understand how to do it consistently on their end. Then, once it was known, a staff physicist for the Chicago machine proved that the bug was also in the Therac 20 software. By performing Fritz's procedure on his older machine, he received similar errors. And a fuse in the machine would blow because they had the hardware detections. The fuse was part of the hardware interlock, which they had taken away because, once again, like the Colorado airport, they were sure that the software solution was going to be better than the hardware. Things got worse. After they knew that they had inherited this bug from the Therac 20 and the lawsuit started to proceed, they started to check the software. Now, it wasn't unusual at this time to program a PDP-11 in assembly language. The PDP-11 had a sweet assembly language. It had lots of nice features that the machines that are RISC machines today, which is reduced instruction set computing. They were a CISC machine. They were a complex instruction set computing hardware because they didn't have RISC back then. And so they were a nice assembly language. Not too many commands, not too few commands. The ones they had that were elaborate were loved by all. But the application didn't use the PDP-11's Unix operating system. They had written their own operating system in assembly language. So the PDP had used corporate written software for the operating system. That means their operating system did not go through as many tests as something they would have purchased from DEC, which had Unix installed on the PDP-11, or from IBM if they'd bought an IBM machine. So this PDP-11 was supposed to be doing real-time control of the machine. Now, I don't know if y'all have had a course in real-time programming or not. Real-time programming is really quite different than just procedural programming. You have to have contingency and backup plans. You have to have ways of saying, okay, I only have 0.2 of a millisecond left. I'm going to finish up this algorithm. It'll not be as good as it was, but it'll still work. You have to have ways of degrading the system. Not something you typically do in procedural programming languages. So this operating system controlled the normal operation and the safety systems. Today, we would use a microcontroller and a GUI for the front end. We wouldn't need this PDP-11, and the microcontroller would already be designed to control particular pieces of hardware. The company never publicly released their source code, but several experts did get a look at it for the investigation, and they were very unhappy. The software was written by a programmer with little experience coding for real-time systems. So where did the company make a mistake? They hired a programmer with very little experience in this device, and they removed the hardware checks at the same time. So they hired a less experienced software person who didn't know maybe some of the tricks of how to do it for a real-time system. The software had very few comments, and it didn't seem as if any timing analysis had been performed on the test cases. They had simply followed the manual. A single programmer wrote the software for the Therac 25 using software from the Therac 6 and the Therac 20. Believe it or not, the programmer no longer worked for the company and could not be found. I will stop here.